to accurately determine the annual operating costs for alternating current motors ranging from 1 to 50 horsepower, whether single-phase or three-phase, follow these steps. Firstly, gather the necessary motor data from the nameplate ratings, specifically the power in horsepower, voltage in volts, current in amps, power factor, and efficiency as a percentage. Secondly, calculate the motor input power in kilowatts. For a single-phase motor, the formula is kilowatts equals voltage in volts multiplied by current in amps multiplied by the power factor. For a three-phase motor, the formula is kilowatts equals 1.732, which is the square root of 3 multiplied by voltage in volts multiplied by current in amps multiplied by the power factor. Thirdly, determine the motor operating time. This involves determining the number of operating hours per day and the number of operating days per year. Fourthly, calculate the annual energy consumption in kilowatt hours. This is done using the formula kilowatt hours equals motor input power in kilowatts multiplied by operating time in hours per day multiplied by operating days in days per year. Fifthly, calculate the annual operating cost in dollars. This is found by multiplying the kilowatt hours by the electricity rate in dollars per kilowatt hour. Let's illustrate this with an example using a 10 horsepower single-phase motor. Assume the motor nameplate ratings are as follows: power is 10 horsepower, voltage is 230 volts, current is 19.2 amps, power factor is 0.85, and efficiency is 85%. The motor operates for 10 hours per day, 300 days per year, and the electricity rate is $0.12 per kilowatt hour. To calculate the input power, we use a formula for single-phase motor: kilowatts equals 230 volts multiplied by 19.2 amps multiplied by 0.85, which equals 3.68 kilowatts. Next, we calculate the annual energy consumption: kilowatt hours equals 3.68 kilowatts multiplied by 10 hours per day multiplied by 300 days per year, which equals 11,040 kilowatt hours. Finally, we calculate the annual cost, which equals 11,040 kilowatt hours multiplied by $0.12 per kilowatt hour, resulting in $1324.80. There are several factors to consider that can influence these calculations. Motor efficiency directly affects energy consumption. Higher efficiency motors will have lower operating costs. Operating the motor at its rated load will minimize energy waste and reduce operating costs. Regular maintenance can help improve motor efficiency and extend its lifespan, reducing operating costs over time. Keep in mind that the method described provides an accurate estimate of operating costs based on nameplate data. However, actual operating costs may vary depending on factors such as load variations, power quality, and environmental conditions.